Now, if you remember, an inequality is something's greater than, or something's less than, or something's greater than, or equal to. So we can say x is greater than 3. That means x could be 4, x would be 25, x would be 86, x would be 3.1, x would be 3.00001, but it can't be 3. It's got to be greater than 3. If I say x is greater than or equal to 3, x can be 3, but it can also be 3.1 or 5 or 28. It just can't be anything less than 3. So these are the greater than, or these are the greater than symbols. Then x is less than 3, or x is less than or equal to 3. Kind of the same analogy. X can be anything up to 3 in this case, and x can be anything up to and including 3 in this case, but it's got to be less than. It can be a negative number, it can be 0. As long as it's less than 3 or less than or equal to 3, then it meets the criteria for these particular symbols. So we've already done the properties of equalities. Now these are the properties of inequalities. And like the other properties, there's the addition, subtraction, multiplication, and division properties of equalities and properties of inequalities. And they pretty much work the same way. There is one trick you have to watch out for, though, and I'll show you that in just a second. So I'm going to kind of use the same examples I used in the first video. So let's just take this. X is greater than 3. Okay. But if I add 2 to the left side, so x plus 2, I have to add 2 to the right side. So x plus 2 is greater than 5. And it makes sense. Okay? And if I use a greater than or equal to, it works the same way. If I use the less than, it works the same way. If I said x is less than 3, then x plus 2 is less than 5. So they all work the same way. Now we're going to use the same example we used in the last one. So I said 3x plus 2, except now I'm going to use an inequality is less than or equal is less than 14, and we want to solve for x. Okay, so use the subtraction property of equality. Subtract 2 from both sides. These will cancel. 2 minus 2 is 0. You bring your 3x down. Bring your inequality down. And 14 minus 2 is 12. So 3x is less than 12. But I still have something in front of the x, not 1. So I want to divide that by 3, and so I have to divide this by 3. So 3 divided by 3 is 1, so I get 1x is less than 12 divided by 3 is 4. So whether you leave the 1x as a 1x or just as an x, it doesn't matter. X is less than 4, and that's how you do that problem. Basically the same way as we did the last one, except instead of an equal sign, it was an inequality. And the inequality always travels down just like the equal sign did. Okay, now we have variables on both sides and using an inequality. In this case, it's greater than or equal to. Okay, and remember, like the last video, you want to get all the variables on one side and all the numbers on the other side. So we can do variables first. Since 2x is smaller, let's get rid of that one by subtracting it out. So if I subtract 2x from both sides, these cancel. Give me 0. 5x minus 2x is 3x. The 6 comes down, so plus 6. The inequality comes down, is greater than or equal to. And 2x minus 2x is 0, so you don't have to write anything. And then the minus 3 comes down. Now we want to get the numbers to the right side since we have the variables on the left side. So let's subtract 6. And then those will cancel because 6 minus 6 is 0. So I get a 3x. And minus 3 minus 6 more is minus 9. And we carry down that inequality. So 3x is greater than or equal to negative 9. Now I want to get the x by itself. So in this case now the division property of equality, I divide both sides by 3. 3 divided by 3 is 1. So I get the x coming down by itself is greater than or equal to negative 9 minus, or divided by 3 is negative 3. So there I get my answer. I've solved it. X is greater than or equal to negative 3. Okay, here's where the little trick comes in that I told you about earlier. If, for example, I move the variables to the right side and the numbers to the left, let's do that. So I want to get rid of this 3 here, but it's negative, so I have to add 3 to get rid of it to make it 0. And I add 3 over here. So now I get 5x plus 9 is greater than or equal to 2x, because those cancel out. So now I want to get the variables on the right side, so I subtract 5x over here. I have to subtract 5x over here. Those will cancel. I get 9 is greater than or equal to 2 minus 5x is negative 3x. Okay, now I need to get that x by itself. So what do I have to divide by to make it equal to 1? I have to divide it by negative 3. I have to divide this by negative 3. Negative 3 divided by negative 3 is 1. And 9 divided by negative 3 is negative 3. So negative 3 on the left and x on the right. Here's where the trick comes in. Anytime you multiply a coefficient, in other words, multiply or divide an inequality by a negative number. See, and I divide it by this negative number here. Anytime I do that, so it's multiply or divide by a negative number, I have to reverse the inequality. And you see the inequality is greater than or equal to, so I have to make it less than or equal to here. So negative 3 is less than or equal to x. And the reason I left this one from the last one we did is because this says x is greater than or equal to negative 3. And you can see they say the same thing, except the x is on the right side, but it is greater than or equal to negative 3 up here. And on the left side here, x is greater than or equal to negative 3. So these both say the same thing. X is greater than or equal to negative 3, except you would read the top one, negative 3 is less than or equal to x, and the bottom one, x is greater than or equal to negative 3. So remember, if you multiply or divide an inequality by a negative number, you have to reverse the inequality symbol. And there you have it.